All right, in this next video, we're going to go ahead and look at the motion problems. So in this video, we're going to look at position, velocity, and acceleration. We've touched on position and velocity. Now we're going to add acceleration. So position, that is always your original function. Okay, if you want to know something about the position of the object, you always use your original. Okay, so this is your original function. So if you want to know how far a particle has traveled, you'd use this one. If you wanted to know a point on the graph, that's going back to your original. Okay. The next thing is your velocity. Remember, velocity is speed, but with direction. So it could be positive and it could be negative. If I have negative speed, that means I'm either going down or in the direction of left. If I have positive speed, it means I'm going up or I'm going to the right. Okay. And what is velocity? Velocity is your derivative. Okay. So the way you guys typically label velocity, the equivalent is it's your average, it's a form of your slope, right? Because it's the slope of your tangent line. It's your slope at one point. And the way we find slope is your y values over your x values. Okay. So the way that you label velocity is, if we go back to our position, say I have an x value, which is measured in time. So let's do seconds, and my output is meters. You would take your y value divided by your x value. So meters per second. Okay, so the way velocity is you plug in seconds and then you get out speed, which is meters per second, or whatever your original function was labeled. Okay, then acceleration, we move on. That is our second derivative or the first derivative of our velocity. Okay, and acceleration is the rate at which your velocity is changing or increasing in the rate of speed. Okay, so acceleration, the way we label acceleration, if I go ahead and do the same thing, since we're taking the derivative, it's the same thing as slope. So I would do my y values over my x values. So my y values are meter per second all over seconds. Okay, and you guys can think about this just like a fraction. So it's meters per second times the reciprocal of this, so 1 over s. So meters per second squared. Okay. So that's how acceleration is labeled. Typically, you once again plug in time, which is seconds, into your equation, and then you would come out and the label would be meters per second squared. Okay. So this is the idea of our motion problems. So position, your label of your outputs would be meters. Velocity is a form of speed, so it's meters per second, and acceleration is meters per second squared, okay, or units per second squared, whatever label you are working in. Okay, so that is the intro to your motion problems.